Problem number 4 of the 2006 MIT Integration Bee Quarterfinals. Quarterfinal number 1. The definite integral from x equals to 0 to x equals to a half of 1 over the square root of x minus x squared. So this is also a fairly easy problem. We have two methods that we'd like to propose. Whatever is of interest to you, please feel free to look into that. Method number 1. So the first thing we'll do is I would pull the square root of x out from the denominator, and that means that now we have square root of x times 1 minus times the square root of the denominator times the square root of 1 minus x, and then we would substitute just to try and remove the complicated square root of x by saying let u be equal to square root of x. Therefore u squared is equals to x, and therefore 2u dx equals to 1, and therefore we can substitute for dx with 2u du, right? And then the limits, when x equals to 0, obviously the square root of 0 is 0. When x equals to a half, we have 1 over square root of 2. So from the x domain, we have 1 over the square root of x times the square root of 1 minus x. That transformed into an integral in the u domain from u equals to 0 to u equals to 1 over square root of 2 of, in the numerator, in place of dx we have 2u du, and then in place of square root of x we have u times the square root of 1 minus u squared. And so what we can do is now we can substitute for u with sine theta, and therefore du d theta is cosine theta, and therefore we can substitute for du with cosine theta d theta. And looking at the limits, when u equals to 0, the arcsine of 0 is 0. The arcsine of 1 over square root of 2 will be pi over 4. So the 2 that we pulled out now becomes a constant, and now we have the integral from theta equals to 0 to theta equals to pi over 4 of, in place of du we have cosine theta d theta, in place of 1 minus square root of square root of 1 minus u squared is the square root of 1 minus sine square theta, which is the same as square root of cosine square theta, which is the same as cosine theta. So we have twice the integral from theta equals to 0 to theta equals to pi over 4 of cosine theta over cosine theta. The cosine thetas would cancel, and so what that means is that we have twice the integral of 1 from theta equals to 0 to theta equals to pi over 4, and that means that we have twice times theta when integrated with the limits applied, so we have twice times pi over 4, and that means that is pi over 2. So it means that the integral from x equals to 0 to x equals to a half of 1 over square root of x minus x squared is the same as pi over 2. So that is method number 1. Now method number 2 is going to be also slightly different. One thing we could do is we could express x minus x squared in the denominator under the square root sign as a quarter minus the square of x minus half squared. And now we can just go ahead and do the substitution by saying let x minus a half be equal to a half sine theta, so that when we now substitute in the sine theta, we have a quarter sine square theta, and this a quarter can be pulled out. So dx d theta now from that a substitution becomes a half cosine theta, and therefore we can now substitute dx with a half cosine theta d theta. The limits, when x equals to 0, we have 0 minus a half equals to half sine theta. Therefore, negative a half equals to sine theta. Negative 1 is equals to sine theta. The arcsine of negative 1 is negative pi over 2. And when x equals to a half, we have half minus a half is 0. 0 divided by a half is 0. Arcsine of 0 is 0. So now we have our problem in the x domain being equal to the integral from x equals 0 to a half of 1 over square root of a quarter minus the square of our x minus 1 as x minus a half, now being equal to the integral from theta equals to negative pi over 2 to 0 of 1 over a quarter minus a quarter sine squared theta times a half cosine theta. So we can pull out a quarter out, so we have a half in the denominator, and this a half now can cancel with the half that is right before the cosine theta in the numerator. So the halves disappear, and now in the denominator we have square root of 1 minus sine squared theta, which is the square root of cosine squared theta, which becomes cosine theta. So we have now the integral from theta equals to negative a half to negative pi over 2 to theta equals to 0 of 1 over cosine theta times cosine theta. The cosine thetas would cancel definitely, and here we have the integral of 1 from theta equals to negative a half pi over 2 to 0, which is now theta, and with the limits as shown here. And the lower limit is negative pi over 2, the upper limit is 0. So when we substitute that in, we have 0 minus pi over 2, which is pi over 2. So it leads us back to the same solution as method 1. So the integral from x equals to 0 to x equals to a half of 1 over the square root of x minus x squared is equals to pi over 2, and that is the answer that was required of us. So yeah, thank you for staying logged. I hope you did enjoy our 2 methods for solving this problem. Until next time, bye bye.